All right, so good. I think it's recording. Yes, it's recording fine. All right, so we are 2 minutes late. All right, so far we have discussed about what is big data. Then we went into the details of HDFS. We also talked about Zookeeper. Okay, so HDFS was for storing a lot of files, use data. Zookeeper was for coordination between various services and applications. Afterwards, we talked about Yarn. Yarn can execute your application in distributed fashion and provides the functionality to distribute the execution. Distribute, it's like a distributed OS. So the common functionalities like figuring out which machines are free, which machines are closer to data, and so on is provided to you by Yarn. While we don't talk to Yarn directly, but if you're planning to develop your own application, then you might use Yarn. I mean, when you want to develop your own product, then you will use Yarn. Now, afterwards, we talked about MapReduce. And MapReduce is nothing but a huge sorting engine which can execute your logic on many machines and then sort the data given out by by your your application and sort it and then aggregate it using the reducer. That's all the MapReduce paradigm was. Here, the important part to note is that you do not have to worry too much about distribution of logic. It will automatically happen. You just have to fine tune it. Fine tune means changing number of mappers, number of reducers, and so on. All right. So, lot of commonly used logic such as select, join, etc. was very difficult to do using pure code because you will have to write all the logic again and again. Therefore, people came up with pig. All right, since the computing, uh, even say you want to group certain data by a particular column, it's fairly time consuming task in case of MapReduce, right? That's where people came up with ideas like pig. Any questions at this point? Okay, good question from Jitendra. So what exactly is Thales and what is the relationship to pig? All right. So what exactly is pig? Pig has two parts to it. One is called pig Latin. That was the programming language, like the operation that we used. Load the data, group the data by a particular column, and so on. That was that was pig Latin, right? And when this pig Latin is interpreted by pig, it under the hood executes as MapReduce. It under the hood gets executed as MapReduce. Now, who does this execution? Who does this conversion? That is the execution engine of pig. So Tez is another execution engine. Tez is another execution engine by Hortonworks. And they have tried to make it really fast. All right. So Tez is nothing but an engine by Hortonworks to make it fast. All right. Any other questions at this point? No questions? Just give me a second. I'm trying to close the curtains. Yes. All right. So yeah. So Kush has a question that we want to discuss about the data pipeline. We'll talk about data pipelining. Don't worry. Okay, because we need to learn a little bit more about the model. Jamil is saying that the data pipeline comes in machine learning. Not really. Data pipeline comes in the data engineering course. Okay. All right. So Thomas's question is MongoDB MapReduce comparable to our MapReduce? Kind of yes. Okay. So kind of yes. I'll explain to you how it is different and how it is same. So in case of MongoDB, when you have to do certain complex processing, although MongoDB provides kind of a query language, just like we kind of, they call it aggregations. They call that kind of query language at aggregations. MongoDB does provide a kind of good query language where you can bisect the data, join, not join, but you can group it, clean it, project it, and so on. And MongoDB stores the data. Okay. Okay. MongoDB stores the data in the form of JSON object. All right. So when you say MapReduce on MongoDB, every record is a JSON object. Okay. So your map function in MongoDB receives the single JSON object on which it operates, meaning your function, map function, will be executed against every document. All right. Yes, that's also at MongoDB label, that's also distributed. Okay. A question from Sapna regarding the assignments. I went through them and wanted to know if we are in position to do them with all that we have learned till now. Yes, you should be able to do it. In case you are not able to do it, just try digging through the PPT a little bit or going through the previous videos, and you should be able to do it. Most likely with the current knowledge itself, you should be able to do it. All right. A question from Jamil. Is it same with Cassandra? Yes, Cassandra too provides us a way of processing data by the way of MapReduce, as well as they provide something called CQL, Cassandra Query Language. All right. So question from Manjunath, how to submit the assignment? Doesn't the UI provides you to input your queries and submit? Big text boxes? Yeah. For problems, there are, you can actually submit the problems in the email. That is good enough. All right. Support at Novik Data should be good email. All right. Okay. So any other questions before we jump into a new topic? So we everybody is with me so far. We talked about big data, HDFS, Zookeeper, Yarn, and MapReduce, and Pig. A question from Kush: does that mean MongoDB store data in distributed manner? Yes, it does. Okay, we're going to discuss it soon. Ted's question is, these MapReduce assignments are optional. You can try these assignments. We will do this assignment again with Spark. That's right. So most of the MapReduce assignment are optional. Thank you, Ted. You can actually send it to all. Okay. And all right. All right. So, okay. So Saptarishi's question is, are we going to discuss lazy evaluation today? We can discuss that part, but okay, let me. We finished our discussion on pig, right? Yesterday, in the last session. Yes, I think we just finished the discussion. Okay, so all right. So what will we do is, Shaptrishi, I'll discuss lazy evaluation during the discussion of Spark. There it'll make more sense. I'll give you the demo and of exactly what do we mean by lazy evaluation. In very single word, if I have to ask, okay. Let me just go back. I think it's better to explain to you before I jump ahead. All right. Okay. So do you, okay. So do you remember this script that we wrote last time? All right. So here is the important idea that, okay. So when we said divs equals to load, nothing much happened. It just made a note of it. Similarly, when we said grouped equals to group something, nothing much happened. Until the point store, until we reach the step number 4, nothing much happened. Every statement just returned as soon as we pressed enter, it moved to the next line. That's an evidence that nothing much happened at that point. Okay, so then when we said average equals to for each, again when we pressed enter, it did not really compute at that point. It just made a note of it. It just made a note of it. Okay, how do I compute AVGED? How do I compute GRPED? And how do I compute DIV? Right? So it's like you go to the restaurant, you place an order, you are a group of people, right? Let's say we are 4 people and we went to a restaurant and we all ordered something, right? I ordered an omelette and somebody else also ordered an omelette and so on. So you can see that there will be many orders. Now imagine there are 2 kinds of waiters. One who is not lazy at all. I told him, uh, get me an omelette. So he just ran to the kitchen to get the omelette without taking another orders from anybody else. Okay. So when I say that, okay, give me the omelette, and then he just ran to the kitchen instead of taking somebody else's order for the omelette from my table, right? Or even listening to my next order. So he just brought the omelette, and then till that point of time, I'm waiting for him to return, right? That's what happens typically in a programming language, right? When we say x equals to y multiplied by 3, as soon as we press enter, x contains the new value, right? So that's what it happens in case of program. I'll show you non-lazy as well as lazy parallelly. Okay, so let's say I'm on Python prompt. You can actually see on say in web console, same thing. Okay, so here on this prompt, as soon as I say x equals to 2 plus 3, x's value has been changed to 5. Okay, it's not lazy. While in case of pig, this divs doesn't really contain the real data. So coming back to our analogy, whereby there is one waiter who just runs to the kitchen as soon as we order something, and there is another waiter who patiently wait for the orders of everybody on your table, and then goes back to the kitchen and tells the cook to prepare the items. And at this point of time, the waiter has the luxury of optimization. As he's walking from your table to the kitchen, he will go through the menu and then say, not menu, he'll go through the orders that you have placed, and then mark the order, mark that, okay, instead of saying omelette, one omelette and two omelette, we just say two omelettes, right? Basically aggregating the things which could be done together so that there is efficiency. All right. Similarly, the waiter will also figure out that what should be done first and what should be done later. Okay, if somebody has ordered an ice cream and an omelette, so the chances are that the person is looking for the mm, omelette first and then the dessert, right? In the same way, when we do the computing, pig and pig Latin would try to figure out which one should be done first, which one should be done later, what are the operations that need to be clubbed together, what are the operations that need to be separated. Okay, did my analogy make sense to you? All right. So yes, most of the data engines, including Pig, Spark, TensorFlow. TensorFlow is a new data engine uh, from Google. So they all perform things in a lazy manner. Okay, they keep on taking orders unless you say execute. And once you say execute, only then they start executing it. All right. So, and why do we do that? The sole idea is, since the operations are intensive, since every operation might be very intensive, we would like to optimize it. We would let the engine, we would let the waiter club things together, order things in a way that they want to execute, and then get it done. All right. So lazy execution is part of most of the data engines that are being built as of today. Unlike R or Python, or any other programming language, whether Python, R, Java, C, most of the operations are instant, except for few cases like you are defining a function. Things don't happen. Function doesn't get executed. It is just evaluated unless somebody calls that function. Okay. All right, so that was a quick overview the of the lazy evaluation. Yes, thank you, Ted. So yes, so at the command number 4 called store, only at that point of time the execution starts happening. At this point of time, Pig will figure out, okay, it has to do something called for each, and for each is happening on grped, and grped is group by, and group by divs, and divs equals to this. So out of this, it will form a MapReduce under the hood. That MapReduce takes input from this file, and key value pairs are prepared based on this column called ticker. Key is ticker, and then in the in the reducer part, after the grouping, this logic will be executed. Okay, so that's the whole process starts here. All right, imagine that you had some more statements here which has nothing to do with averaged. Okay, let us say for time being, for argument's sake, that our query was something like this. Okay, let me open. All right. Okay, so what is the date today? All right. Okay, so let's say that we had one more method here called one. Okay, and let's say here we were grouping by. Now, when we call store, right, this will not be executed. It'll be skipped because for it goes in the reverse manner. What do I need for this particular thing? For this, we need these things, and for this we need divs. Okay, for this we need this. So this will be skipped. When we say store, this will be skipped. No, it won't be counted in the execution. All right. All right, so that was a quick recap of how a Piglet in Pig script is executed. All right, now coming back to Hive. What exactly is Hive? We are going to go ahead. All right, now let me try to clear the value proposition. Okay, so MapReduce was great, but how do you move existing users to MapReduce? Okay, so MapReduce is great, but how do you move existing relational data, SQL infrastructure? What does it mean? There'll be a lot of data. As of today, when we think about information technology and an organization, probably everybody knows what is a database. And the entire data, starting with payroll and payroll, sales, accounting, everything, and uh, other the product, the services related data, everything is inside database. So your data is inside database, and almost every IT person would know about SQL and database, right? So when you have this kind of if you have this kind of humongous infra already and such a massive adoption already, how would you move them? How would you make them adopt to write MapReduce? MapReduce is anyway not fun, right? Or how would you move them to Pig? Because Pig is again a new language. So the question always come that why would you do that? Okay, why would you move to Pig when we were always happy with SQL? So that is the reason why SQL comes into play. And in very simple words, if you ask me what is Hive, Hive is nothing but an engine that gives you this ability to write your logic in SQL, and it will convert that logic into MapReduce. Hive converts SQL into MapReduce, or while executing SQL, it executes as MapReduce. Okay, so that's Hive. All right, that's Hive. So sixth question is, what is the difference between Hive and Pig? So Hive gives you proper SQL while Pig does not. Okay, Pig gives a different kind of language. Okay, Jitin's question is, any scenarios encountered when SQL was not translated in write MapReduce? Okay, so wherever we are trying to do joins, there is a difference between what do we consider join in SQL and what we consider join in MapReduce. You will see that as we go forward. Okay, those are the things that we'll discuss as we go ahead. All right. Now, Hive's value proposition is this. It's mostly suitable for data warehouses when you are trying to analyze static data. Okay. And you don't require fast response. On an average, if you try to execute an SQL query, even on a significantly big data, significantly huge data, SQL query actually gives you the output in few seconds, right? And on like 1,000 records, 10,000 records, an SQL query gives you the result in milliseconds, right? In the usual SQL databases. But in case of Hive, you cannot expect that kind of response. If you don't expect, I mean, if you are okay with that, then you can use Hive. Okay. It makes easier to port existing projects. Provides SQL dialect called HiveQL, maintains metastore like so it I'll talk about metastore a while later. Okay, and allows HDFS files and HBase querying. Let's say so. Okay. So let me put things in perspective. So I told you that using Hive, you can write your queries in SQL. So you will write kind of SQL that will get executed as MapReduce. So it's obvious that your Hive queries will be querying the data that is in HDFS, correct? Now, there are few limitations. All earlier versions of Hive did not provide record label modifications, and still the update, insert, and delete are yet in very nascent stages. I think last year only, not last year, this year around March, they launched this feature whereby Hive can modify the files update, insert, and delete. Okay, so Hive still remains as a query engine. Hive is not really a database. A database gives you the entire operations like create, insert data, update data, delete data, and then usual database, the standard database gives you transactions. But Hive, as of today, is generally used for querying data. Okay, so two limitations. One, it is little slow. Second, it does not let you modify data, but it lets you create new tables. It's not suitable for OLTP, where queries have higher latency. OLTP stands for online transaction processing. Okay, so all right. So it is not suitable for OLTP because the queries, as you must have seen by now, that whenever we are executing MapReduce job, it takes some time to get executed. It doesn't finish immediately. Okay. It's best when you have huge data set that you want to query, and this data set doesn't change very often. Okay. So if you have a relatively static data set that is maintained in mind, that needs to be maintained in mind. So that is the best use case of Hive. So question from Priya is, what is the practical use case of Hive? Okay. Let's say you have humongous data lying in HDFS. Okay. And you want to query it. Okay. You want to query it for various kinds of use case. In those cases, Hive could be your instantaneous answer. All right. I think a better thing rather than jumping into theory, what we should do is we should do a hands-on. I'll talk about these modules later on. Okay. Again, after trying to do a little hands-on. Okay. All right. I think let's just try to create a table and database and then move from there. I think that's better. Okay. I will talk about architecture in a minute, maybe. All right, I'll talk about architecture around. Okay, so maybe after 10 minutes. Okay, let's try to log in and try to execute our first command. Okay, so a way to execute your Hive query could be, you could go to Hue. And how do you go to Hue? Go to MyLab. Okay, this question from Mohit. Question is, shouldn't using MapReduce take lesser time than not using it? The delta is very insignificant. Okay, because translating SQL query into MapReduce would take hardly a millisecond or two. Okay, while a MapReduce typically takes few seconds, so milliseconds over few seconds would be insignificant. A question from Priya, is Hive the best one to do the job? Else, with the limited use of it, why? Yeah. So when you're querying the data, humongous data on Hadoop, what options do we have? Let's try to weigh those possibilities. Okay. What options do we have? One, write MapReduce. Okay. So scenario is this: you have humongous data, say 1 TB or say 10 TB. Okay. And the data is kind of structured data. Okay. Structured or semi-structured, meaning let's imagine that it's a comma separated or tab separated values. Okay. Now, since you have comma separated and tab separated value, what you can do is, okay, you have this kind of data. And now question to you is, how would you churn it? How would you process it? Let's say what you want to do is find out, this data is, let's say, about stock market, right? Let's say this data is about stock market. And the question is find out which, find out which, okay, find out the minimum value or minimum 10 values of a particular stock. Okay, let's say this is the data. Now question to you is, if you are faced with this kind of problem, what are your options? What are your options to process this data? Yes, first one I think is MapReduce. Second, you could also put it in, okay, you could also put it in, say, MongoDB. I'm trying to see what all is possible. You will upload it into MongoDB, Cassandra, etc., and then use their query language. Okay. The other option is use Piglatin. Okay. Fourth option, what Anup is suggesting, use Redshift. But keep in mind that for Redshift, you have to keep uploading this data to the Redshift data store. Okay. All right. Sabna says, let's use the SQL, say Oracle, but on 10 TB data, it'll be very, very slow. Okay. With MongoDB and Cassandra, you'll have to use their query language or you will have to use MapReduce. Okay. All right. Third is use Hive. In here, you will have to write the code or say Unix shell script or Python. Okay. You'll have to do it in either in Java, Unix shell script, or Python. Use Piglatin, or you could use Hive. Okay. In Hive, you just have to write SQL. Okay, so here are our all possibilities. One is use MapReduce. You will have to write Java, Unix shell script, or Python. You will either use Piglatin, Piglatin, as in you will write Piglatin and then process it. The third is Hive. The third is Hive that we will discuss. Next is, sorry, this is a 4, this is a 5, this is a 6, and 7 is we will use Spark. That's future. Okay, we will learn that part. All right. In there we have two options: A with Spark or coding. with Hive. Okay, R coding. All right. So these are the kind of options when we talk about computing. All right. Okay. Question from another is in Hive, I will import the data in tables and not use the insert command. So yes, we will talk about it. So we'll try to demonstrate, and then we will try to understand how it works. Okay? Or should we do this? We all first try to run our code, and then we later on go into theory. What do you say? I have seen great results with this kind of model, because right now, if we talk about theory, it'll go into kind of deaf ears. And okay, Thomas. All right, let me just jump to the end. It might look awkward. It might look awkward, but because I think most of my class is fairly hands-on by now, and therefore I can take this kind of risk to jump to the problem first and then talk about theory later. Okay? All right. Let's try to do a nice hands-on. It's actually too much of theory. Okay, so we are going to do something different here. All right. I'm going to first create a table. Okay. So is everybody with me on this? We can go to lab credentials, and then in the lab credentials, we could go to Hue. See that? Okay. So for me, it's already logged in. Is everybody in Hue by now? Great. All right. So or let me take a simpler example that should give you a good idea. There are three examples which I've taken in this. Okay. All right. Okay. So here we go. This is one example. Let me just keep it aside. And then there is another example. All right. Go. Yes. All right. So I have already capped it somewhere. And all right, let's first prepare data. So we go to, we go to file browser. Okay, so everybody here in the file browser, in case your file browser is not opening, you can directly type this. In case you don't see the link, for some people, this file browser doesn't show up. There is some browser incompatibility problems. Okay, so if you go into say data, and inside data you will see this data set. Okay, do you see this data? So it's at the top level, data, ML, this, and here. In case you don't, you directly click on the link. Okay, so this data is from a website called Movie Lens, meaning this particular user ID, and basically it's a rating on movies. People have given various ratings to the movies they have watched. Okay, and the ratings are out of 5. Okay, this number represents the user ID, this number represents movie ID, and this number represents rating, and this is the timestamp. Timestamp is generally counted as milliseconds since 1st January 1970. Okay, that's the epoch. So this is milliseconds since 1st January 1970. All right, so let's copy this data. Let's just select this particular file, particular file, and say copy. Okay, we're copying it to your home folder. Click on home, and that's it. Okay, all right, so what you see here is not this one. Did it even come here? Yeah, it's here. Right, have you copied it, everyone? Okay, do you all have a copy of this data so that you can all practice along with me? All right. All right. The other thing that you can do is, let me also try to do something. Okay, data browser, space. I haven't done it before, but I'd love to do it. Okay, so once you are done with that, you can click on Hive Editor from the menu. You can see Query Editor Hive. Okay, so you can say here, all right. You can create your own database. Okay, create database and give it your name. Okay, whatever you want to prefer, you can do that. Okay, so I'm going to say Sandeep Giri. Okay, just a second, no single quotes, and it should work. Okay, it says that the database already exists. All right, so similarly, you can give your own login and create the database. Okay, instead of Sandeep Giri, say something else. Okay, and once you're done with that, you will have to refresh, and the database will appear here. Okay, I can also say drop database and say Sandeep Giri. Okay, it is asking me to first drop the tables, but I'm not going to do that. Okay, I'm going to drop table NYSE. Is everybody able to create their own database? Select the database from the menu. If it's not appearing in the menu, just click on refresh. All right. All right. I have deleted the tables, what were there. You don't have to delete. Okay, so, all right. Now we have kind of created a database and also have created a table, right? We have not created a table actually, sorry. So yes, all right. So first thing we have to do is we have to create table. Okay, and I'm going to say create table u underscore data, and I'm going to also say location is u dot data. Let me see if it works. Also, what error are you getting while creating database? It would have created once you click on execute. It just have to click on refresh. It should appear there. Okay. All right. It did not show up in the dropdown. Okay, Ali and Sheikh are facing the problem. Okay, I'll share. Okay, so Sheikh, did you refresh it and can you? I think Ali's code is working. I should be able to see. Okay, this is that refresh button. Ali, what was the problem for yours? You had to refresh the whole browser. Okay. So Stephanie, where are you stuck? Okay. All right. Let me also, in the meantime, try to execute this and see if this is correct or not. And in the meantime, I will. Okay. So is it not letting you execute the create database again? Okay. Okay. So if you try to search here, it's not happening. Even after refreshing from the menu. So, okay, what's the name of your database? And if you try to execute it, say create database Stephanie, interesting. It says that the database Stephanie already exists. If I say use, okay, you can use this also as well. This is a bug. Interesting that we found it. Okay. All right. Mishra, can you also try the same thing? I think it's not that. I think there's something wrong with this their menu, and that may be the issue. Okay. Maybe it's taking too much time to refresh. Or maybe it's not showing anything beyond SG because Ash Mishra and Stephanie both have more than this. So maybe that limit is there. Yeah. Maybe Tad is also having the same problem because Tad would be after this. That's my guess. All right. We are yet to remove the old students data. Okay. And that's why we generally wait for some time before we delete people's data. Okay. No, Anup, you can see here. Yeah, I can see. All right, let me try to see if we can execute this. Okay. All right, let me just take a look at the exact syntax. This is kind of correct. Just a second. This is correct. Just let me also see if Okay. Okay. So you are right. All right. Anup is right. So yeah, good. Let me do this. So one thing is one more mistake we did was instead of creating a folder, we have created a file. So let's create one folder here. Okay. So we are saying here, we are saying new directory, and we are saying, let's say ML 100K. All right, that's the folder we are creating. Okay, so let me again try to put down what we are doing. Create database, Sandeep Giri, that's first thing we did. Then using Hue, we copied slash data slash ML 100K and u.data. All right. Before that, we could have basically created using Hue, created directory called ML100K. Okay. So this everybody is done. Can we create a Hue directory ML100K in your home directory here? Okay. Let's create this directory ML100K. This is HDFS, so we can also use Hadoop from the console. We can do everything from the console as well. Okay, you see new directory on the right top. This is how you create. Yes? All right, done? No, you have to go to home. Okay, in your home directory, click on home, then click on new and directory. Okay, so I would prefer to, if you create it with the name called ML100K. So in your home directory, which will be something like user, then followed by a login name. So Nada, yes, that we can do, but we'll try to use the UI today. Okay, you can use both. All right, so everybody has created this folder called ML100K. And let me do it. Okay, now let's copy this data. Let's copy this particular data into your home directory slash ML100K. Okay, ML100K. Okay, how do you do that? We are going to go to the data folder. Okay, we are in data folder now. You can see ML100K. Yes, and there you see u.data. Okay, we can drag it. So we can say actions and move and go to home and then write the name here. Okay, sorry, not move, copy. Extremely sorry. Okay, so click on, go to the data folder, and this data folder is in this location, /data /data /ML100K. Go to the top level. Sure, sure. So, okay. Sundar, you can share your screen. Yes. Okay. So Sundar, you can share your screen and okay. All right. Good. So you have created this folder. Now go to the top level. You see the first slash before user, before you, there, yeah, yes, that slash. Click on that. Yes. Click on data. Yes. Okay. Click on data. Yes, you're at right position. Go down. Go down. You see ML 100K. Click on that. And there you see u.data. U.data. Go back. Go back. Yeah. Check. Do the check. I mean, tick. Yeah. Click on actions and then copy. Copy. And then you click on home there at the top. Okay, scroll down a bit. Okay. All right. So I think you can just simply say after this username of yours, you can just say slash and you can give the folder name slash folder name ML 100K. Right? That's it. Click on copy. Now go click on home directory. Good. Okay. So click on ML 100K. Yeah. You see, it is there now. That's okay. That's okay. All right. So is everybody able to do it now? All right. Okay. So now, okay. So if, yes, Sundar's question is, I was wondering about group not showing HDFS. Yeah. So that's the general way because every file is kind of editable by HDFS file, HDFS username. And that's why. Okay. So here we are following a different policy. All right. I think I created in the, okay. Sorry, Anup, I think I created in your folder. Okay. By default, it keeps it right only. Okay. So, all right. So now I'm going to give you this. Change the login name. Okay. All of you should change the login name here. Here. Change this login name to yours and then execute it. I have, oh, sorry. I shared it only with the person. Okay. So I'm saying here, so first what we did so far is we copied the data from a central location to our home directory so that we can experiment a little better. And then we created a table We created a table and we are defining the location of the data. All right. And also we are saying that our data is in the form of tab separated. So we are saying create my table, which will have these 4 columns, and then we will have row formatted data separated by /t. Okay, so we are saying kind of the way our input split worked. Okay, so table name you can keep anything. Sheik, you can keep the table name anything. It's up to you. All right, good question. Just that you provide the appropriate location. All right, so we are saying that this table is going to be kind of a window to the world of our data. Our data is here. And how does this data get translated into the table? By this line. It says that the row format is delimited, terminated by tab. Correct. That's a very good question, Sheikh. Had there been more than one files in this particular folder, you can try doing that, okay? If you, later on I'll show you, you can basically click on action and click on copy, give it different name, and it should have, you can basically make more copies of it, okay? Then all will be translated, yes. Okay, so everybody with me or so far? If anybody is stuck, I would love to help you at this point. So we created a table where, and we told the table that your underlying data is in HDFS. Yes, Karthik. If you have multiple files, you will put generally in one table. Okay. Because this table is not loaded into the memory, so it's okay. This table is just one representation. Also, Karthik, we will talk about something called partitioning later on. Manjunath's question is there a primary key concept in Hive? Not really. So TAD is not able to create the database. So can you just type use database and then give the name of the database? You want me to take a look at your machine? TAD? I'm stopping to share. You can share your screen. Will that be okay? Okay, I've stopped sharing. You can share now. Stephanie's question is the table populated at this point? Yes. Each table is a folder? Yes. Each table basically has a location, which is a folder. Okay. So in case you are getting table exist and you just check whether you have selected the right database or not, use database and you give your own table name, your own database name. Okay, so Ted, can you try executing that create database one? All right. So now instead of create, can you just say use? Use. Yeah. Use database Ted. Error while cannot recognize near database. You remove the semicolon at the end of it, or you cut paste. Yeah, remove the semicolon. I think this it should work. It always works. All right, let's do something simple. Just create a database. Create database again. Create database. And before that, write 202016 underscore TAD. Yeah, that should be good. Just run it. All right, now refresh it. Yeah, just search for 2016. Not this one, not this one. Okay, actually you have to write use. Okay, use TAD. Simply use TAD. That's it. Space TAD. That's it. Yeah. After this, after use TAD, you can write that query. Remove the first line. Yeah. After use TAD, you can write the other query. Just select everything. Just select everything, including use TAD. Yeah. Yeah. Put semicolon just after TAD. Just after TAD. Yeah. That's it. Select everything. Click. Good. So that means the table has been created. Try refreshing this window. I'm actually wondering what's happening here. All right. This is, yeah. Because is the drop down showing anything? Click on drop down. 2016 type 20. Yeah. Now you'll have to create another table then. All right. So you have two databases. One is in, okay. So you remove the use TAD statement and then you'll be able to create there. So you can select the database either by typing the command called useTAD or by using the dropdown. Remove the first line, yeah, and then execute. Yeah, good. Now click on refresh. Yeah, you can see that. Good. All right. So anybody else facing the problem? Great, great. Stephanie? All right, all right. So let me just check if my u underscore data has anything in it. Mm-hmm. I think I have deleted the table or something. Okay. Let me just copy it again. I don't think I've copied it. Okay, in this, click on home directory, then say ML movie lens 100K and say copy. Okay, so now if I go to home directory and go there in this, I sort my data by date. And now I have the table. I have this file. Okay, I have this file. I have the folder. Now I can click on. All right. So it's basically loading this data as a table. Okay, so who is stuck now? All right, everyone. So we did pretty simple things. We did, okay, first we created our database, okay, then selected that database, okay. Sure, I'll share the table. All right. Yes, that's right, Kush. That Hive will fetch the data from the file whenever we select the data. Yes. All right, so yes, Ali, Anup, Arslan, Barsa, Jamil, Jinyang, Jitendra, Karthik, Kush, Manjunath, Mohit, Nada, Nitin, Omkar, Prashant, Priya, Ramana, Sapnas, Saptrishi, Sheikh, Mishra, Stephanie, and Sundar, and Ted. Okay, so Jinyang, you are seeing the empty data the way I was seeing, right? In my case, the problem was that the file I did not copy the file in the correct location. Okay. Just check the location, this location folder, is it correct or not, as well as whether in this folder the data exists or not. Okay. So Karthik's question is, so this database created is on HDFS, so we can create databases on HDFS directly or use, so no. So this database is in Hive. We'll talk about it in a while. So Hive keeps metadata like the name of the table, name of the database, and the columns separately. Okay. All right. So can I see your screen, Jinyan? I'll stop sharing. You can share your screen. So directory is in HDFS, database and table is in Hive. That's correct. All right. So, okay. So you have u underscore data. All right. And can you show me the table name as well? Create database. Okay, it's table. All right. And it is stored in ML 100K and this. Okay. All right. So here we are saying create table ML 100K u dot data. This is correct. And okay, that's good. Remove this file name, please. Remove the file name. Keep only the directory. No, no, not this one. ml100k slash ml. Yeah, remove that. That's it. Okay, give let's say 4 here. That's it. Execute it. Yes. Now let's try to see. Let's say select star from u underscore data 4. All right. Now let's go to the file browser. Click on home directory. Okay. So I think it is the capitalization. I think K is capital there. That is the problem. So if you try to rename it, okay. Yeah, yeah. It's click on checkbox and then action, rename, make it small k. Oh, it is already there. Good, good. All right. So both are there actually. Okay, okay. I go back there. I think L is also capital. Go back in your query, please. I think, okay. So yes, recent run queries. All right. Yeah, click on one of those. Yes, wait. Yeah. So here just put 5. I think this L is good. Okay. This is correct only. Okay. Is the folder name correct? JYANG3517. Yeah. Okay. All right. This time it worked. I think it was there's something wrong with the file naming. Good. All right. So good. Prashant's question is, so Hive stores matter. Just give me a second, Prashant. I'll keep a note of these questions. These are very good questions. The second one I'll answer now. So Hive stores metadata regarding a file which help it read the file like a table. That's correct. Okay, Prashant's next question is, what will happen if there are two files with different record types in the same folder? It will give an error or it'll skip those records. You can try this. All right. And it'll try its best to split it based on tab and put nulls where it's not able to load and so on. Okay. All right. Great, Zinyan. So third question from Prashant is, if same record type, does it auto union concat? It automatically concatenate. All right. Similar to like MapReduce, when we are running our MapReduce query, in the input, if we give folder instead of file, it concatenates all the files into one and keep it there. Karthik says, consider an Excel file with multiple worksheet, how to move a single table. Okay. All right, good question, Karthik. Karthik, the idea there would be export it as CSV, multiple CSVs, and then put all those CSVs in a single folder. All right. or create different folder for each CSV. Make sense to you, Karthik? All right, so I hope that everybody is able to execute the recent query, because these steps would have answered your many questions subconsciously. Okay, so 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 in case you're stuck, you you know let me know if I can fix it. If you're stuck, I can help you solve it. Saptarji's question is, I'm wondering how will we handle if there were multiple split data files in this file, what you see here, it might be internally split. Okay, so that all complications of blocks and replica sets and so on is hidden from the developer, and HDFS provides that layer. Okay, so that's not a concern with us. All right. All right, great, Priya. Anybody else need help at this point? I hope everybody is able to do it. If you're stuck, give it give me a chance. I can help you out right now, so that we all are on the same page. Okay. All right, great. So this was our first exercise. Now, what I want to show you is something very simple. Now, there is this table called U underscore data, right? And let's say we want to do something very complicated. Say, for example, we want to find out per movie ID the average rating. The average rating. Okay? So I can simply say something like this. All right. So where did I go wrong? Yes, thank you very much. Goodbye movie ID. Yeah. All right. Okay. So now this one is taking some time. Yes. Thank you, everyone. All right. So you can see that the average ratings of the movies is this. Good. All right. So now what we just observed is that once we create this table, rest of the life became easier. And that is the thumb rule about Hive. Okay. There's a thumb rule about Hive that once you have table in place, everything else is easier. Okay. So everybody is with me and comfortable so far. We will talk about theory now because now it'll make sense to you. Okay. So let's take a break for 10 minutes. Back by 9:45, 46 p.m. IST. All right, so I'm back. Should we start now? Okay, so two more questions and that should be good. How is this different from Oracle external table? Same can be achieved. Good, yes. Same can be achieved using Oracle external table in the same way. Okay, so now can somebody answer this question? Who can answer this question? Yes, let me see. That's right. That's right. So when the data is humongous, when we talked about say 10 terabyte data, getting it done via Oracle is difficult. Okay, not because the software is not great, but because there are hardware limitations. All right, and those hardware limitations are not with respect to the processor, but with respect to the discrete speed, and therefore that kind of data can generally and should generally be handled with respect to on the kind of distributed computing. So if you have terabytes of data, it's better to run it on the cluster than using a single computer with Oracle or anything else. Okay, do it make sense, Jitendra? Okay, a question from Barsa. Can we see the MapReduce code it has created to process the query? No, you can't. All right, because it really does not create the Java code. Instead, it basically kind of does the binding. Okay, it kind of does the binding. So it doesn't really generate the code. A question from Prasant. I have question regarding my, just a second. Okay, go ahead, Prasant. All right, all right. So maybe sometimes it gets stuck. And is it still running? You can refresh the window and try executing the same command. All right. So sometimes the job can get stuck or something could have happened. All right. All right. Let me see if we can. So let me go through the job browser and I can see my jobs. All right. And your jobs will be this one, right? This one is running. So there are quite a few jobs actually are running right now. All right. So let them, it might take some time to finish. Okay. Now you got the error saying this one failed, but okay, this one failed, this succeeded. All right. Barsa, your job is also running still? Okay. Yes, Sundar, you can see that. You can see that using explain. All right. All right. So some jobs are running and some are failing. Okay. Those jobs are running. In case you can try, you can retry that. And if possible, you can go to job browser and not this way. There should be another way. Okay. I think those jobs which have succeeded, I'm not able to open their details. All right. So, okay. I'm just trying to see if I too get an error. I think it just overloaded and or some other problems are happening. I think it's still opening. It's waiting for opening that session. It says accepted. All right. So, okay. So you can try after some time. See, for me also, it seems to get stuck somewhere. All right. I think it'll take some more time to finish. Never mind. Okay, so Priya, were you able to execute select star from u underscore data? Okay, all right, let me, okay. Okay, so, all right, let's try to do a simple thing first. Okay. Select star from u underscore data. Okay, where u underscore data. Okay, so this is running fine. It's just that I think the particular node on which this file is residing, that is kind of overloaded. All right, that could be one issue. I'm just trying to take a look at all the nodes and trying to see if all right. So nodes are okay. There are a few services that we have turned off by ourselves, which is all right. So I don't find a problem as such. So, okay, correct. So let's move on and try to debug and offline. Give me a shout and I will connect with you, or somebody else from my team will connect with you. Okay? Maybe after the session you can try it out. Cool. Yes. Thank you, Ted, for reminding that. Okay, let's move on. All right. So what we did just now was a simple Hive work, and it made our life really, really simple. Okay. And okay, as a quick recap, what we did was we first created a folder, copied the data into that folder, and then create a table on top of this data which we have recently copied, and then started querying that table. Okay, and and so on. Now, there are a few things that we must have noticed by now, that even though we refreshed our window, the table existed, correct? Unlike in case of a pig, if you create a data set and you exit and come back again, log in into the console again and start pig again, the data set no longer exists, correct? Now, how does Hive achieves it? By the way of Metastore. Okay, so when we created a database or created a table, it essentially made an entry into Metastore. And where is this Metastore? It's not in HDFS. It's in proper MySQL. We have a MySQL database, the standard relational database, and that's what is storing Metastore. Okay. Here, the assumption is that the number of tables will not grow beyond, a number of tables will not grow such that a usual database can't handle it. That's why it's okay to keep the name of the database and tables, their columns, and so on in this Metastore. This Metastore is something which gets updated when you say create database or create table. All right. Now, who is this driver? So what you see here is, you are aware of this part. This is Hadoop. The diagram points to the older Hadoop, but it's using Yarn here. So there is a file system and there is a Yarn. Okay. So Hive's driver is the one which consults Metastore, and whenever we are saying select movie ID, comma average of the rating from the table, when we are saying that query, this driver is consulting Metastore, checking if such a table exists. If it exists, where is the data? So this name of the data is also kept in the Metastore. So after consulting, after finding the definition of the table, this driver will convert that query into MapReduce and then hand it over to Hadoop. Okay, I hope this is clear at this point. Now, how do you interact with Hive? These are the two components that are the heart of Hive. There are many layers on top of Hive. One is CLI, Then there is a Hive web interface. CLI means command line interface, Hive web interface. Thrift server. Thrift server is a way of providing service, and thrift servers can be used via JDBC or ODBC or anything. Thrift server is basically a very nice way of providing the service. Okay, so I'll explain what does it mean by thrift server. Thrift service is an open source project. It's an open source project, and it was open sourced by a company called Twitter. They open sourced that service. And what's the advantage? Let's say you are writing a simple phone book service, okay, as an online web service to which people will query, and then get the phone number or get the name of the person and so on. If you are trying to build a service, thrift server is a very nice engine because it converts your service into all possible languages. Okay, some people who are using C, they can use your service. People who are using Python, PHP, and all kinds of languages, it would generate the client in all kinds of languages. So you don't have to do that. Okay. Another benefit of thrift server is that it makes it automatically very restful. Okay, restful as in uh, simplified. Okay, for time being, let's just stick with the definition. All right. So instead of implementing all kinds of languages, Hive server basically provided a thrift service over which there is JDBC and ODBC drivers, and they connect. So in very simple words, Hive can be contacted from outside. Okay. Unlike Pig, where it was just a command line, here there's a server, there's a Hive server, which answers to the people's query all the time. All right. And the web interface, which we are using, is essentially talking to the same server. It's talking to the same server. The Hue is talking to the same thrift server. Now, it's not talking to thrift server, it's talking to Hive web interface. All right. Now, that also answers few more questions. What if I have a traditional BI, traditional business intelligence tool, say BERT or say Crystal Report, and I want to present the results in those kind of data, those kind of visualization tools. Let's say I have Tableau, you have you have some BERT. Now we want to display this results of select star from U underscore data. How will be displayed? Or you have Microsoft Excel and you are doing sentiment analysis, and the results of sentiment analysis you want to display in Microsoft Excel because that's what your organization is familiar with. In all those cases, you can always install the Java driver and then connect to Thrift server. Okay, so Hive, the Hive web server runs on 10,000 port, and your login and password are valid there. Okay, your login and password are valid there, and you can connect to this server and start visualizing the table that you created, the U underscore data that you created. You can visualize that. All right, is the architecture clear to you? There is Hadoop, there is driver, there is Metastore, and there is a web server. Yes. Yes. Am I audible to everyone? Okay. I got scared that, all right, nobody's, okay. Now, question from Tad is Thrift server is like a web server? No, actually, it gives you a binary kind of in out. It basically, it gives you that interface as well, the web server service interface. Okay. It's more like a web service, but it is kind of, how should I say, uh, it's not only HTTP, it provides TCP connections as well. Okay. It does provide a web interface. A question from Karthik, can Pig interact with Hive tables as well? Yes, Pig does provide that interface, but you'll have to add some more extra library. Substitution question is there a specific message format to interact with web server? You can take a look at Hive web interface. They have a proper API to interact with it. All right. Anoop's question is Scoop similar to Hue, but used only in case of Cloudera? Not really. Hue is a proper web interface, while Scoop is just another command. And this Scoop command is very rudimentary. It's equivalent to copying using Hadoop FS, copy from here to there. We'll talk about Scoop with examples. All right, don't worry. A question was that is Metastore replicated? Answer is no. Okay. Second question, Metastore always needs to be SQL Server or any other database. Yes, any database that supports JDBC, Metastore can be kept there. And almost every database supports JDBC. All right. Okay, so that's you know, the general idea about Hive architecture. All right, so this we have already talked about how to get started. Now, there is console as well. Those who are interested and like console, they can use the command from there also. So let me open the web console. All right. All right. So here, if you go and say Hive, you will see the console. All right. Let it open. Okay, so here I can say use Sandeep Giri. That's my database. Okay, and can say show tables. It shows me the tables. Good. And then can say select star from u underscore data. And I can say limit 10. Just show me 10 records. All right. I'm going to copy paste it to all of you. All right, so that you can try it out. Okay, so what you saw is the console interface to interact with Hive. But this console interface is kind of, it does not support many parallel connection. That's why we avoid it. All right. Okay, so we have this console where you have you can execute the HDFS commands. You can load a Hive script. The commands start with double dash. Sometimes you might need the environment variables, and sometimes you may want to execute the query from the shell script. Okay, you might want to execute one particular command from the Hive prompt itself. In those cases, you can use Hive -e, and you have the Hive prompt. You can execute shell commands with ls-la. All right. So with respect to data type, the important thing to remember is that Hive tries to be compatible with your existing queries. Therefore, you will find duplicate data types. For example, there is binary and there is Boolean. You can see that there is binary and there is Boolean. And for string, you have string, varchar, and character, so that Hive team is trying their best so that you don't have to migrate your existing tables, existing queries, or existing uh, applications, and they're trying hard so that you don't always have to keep translating the entire thing. Okay, so you can see that there are all kinds of data types. All right, and there are complex data types. These data types are something very similar to Postgres or Oracle. So you have array kind of data type. You have map. Map is a collection of key value pairs. Struct is more like your class or structure in C, whereby there are only fixed set of column names and the values there, value you can put. And then union. Union is for the cases where a single column is used for different purposes. Okay, let's say you are trying to keep data from 3 different places, although the significance of data is same, but types are 3 different. For example, let's say people at CloudX Lab, they sign up from Google, sign up from using Facebook ID and somewhere else, right? Everything else is same except the last column called auth. It could contain the email ID, it could contain the Google ID or Facebook ID. They could be different data types, right? That's why in these scenarios, you generally keep a single data type called union. All right. You can create databases using show database, create database, okay, and you can see the list of existing databases using show database, and you can create database using create database syntax. And in case you want to drop an existing database, you can drop it, provided you have deleted all the tables from it. Okay. All right. So a question from Sapna: when I type Hive, it does not go to Hive command in Web Console. It should go after logging in. What error do you get? It might be taking some time because, as I was telling you, that it might be waiting for getting the number of connections. Hive server does not allow more than 10 connections at a time. So we have installed 2 servers and there are 20 total connections. That's why we were trying to use the web interface. All right. All right. So you can describe the table, describe formatted, and so on. All right. So if you want to see the details of any table at any point, you can use describe command. In case you want a proper, neatly formatted, prefer the last command. Command is something you can use for understanding the details about my table. All right. Now, this is a little theory. So there are two kinds of tables, managed tables and external table. Okay. Before we jump into anything, try not to delete your table. If you delete your table called u underscore data by saying drop table and the table name, it will delete the file in the HDFS as well. Why? Because the table that we created is managed table. The difference between managed and external is very simple. Okay. If you drop managed table, it will delete the data. If you drop external table, it will not delete the data. Okay, that's the only difference. Hive Metastore we have already talked about. It stores the metadata of tables in a database, in a relational database, RDBMS. And metadata means what all DBs are there, which all databases are there in Hive, and which all tables are there in each database. All of this information, along with the name of the tables and so on, is kept in the Metastore. Okay, so this is called a managed table. Inside managed table, you can, let's say, what we did just now is we first created the data, then we created a table. Okay, if let's say you created the table first and you wanted to load the data, there are two ways to it. Let's say we created the folder and we want to add more data to it. Okay, one way is directly copy the data into the folder. That's one way. Second way is using the command called load. If you want to upload data from console, which means local data, that means you can use load data local. If you want to load data from HDFS, you can simply say load data in path and load it without using the local keyword. All right. So there are two ways to load data in u underscore data or in any table. Either either just copy the file into the destination table. In that case, you will have to first find out the location of the table. Okay, if it was automatically created, and there you copy the data. And with respect to the location, please keep in mind that if we do not specify the location, it creates the database, it creates the table, it creates the folder automatically here. Okay, automatically inside this location. What do you call this? All right. So yes, very good question, Sheikh. I'll answer that question. So Hadoop fs minus ls slash what is that? It's called all right. So here it would be in apps. Okay. Hive warehouse. So if you do not specify the location of a file, okay, this is where it's going to keep the data. Okay, for me it would be there somewhere here as well. All right, so By default, if you just log in and don't select any table, then this is you don't select any database and you don't specify location. In that case, this is where it's going to get located. All right. So if you don't mention the location of your table, then it's going to be located in the warehouse folder. Okay. This is the default location. All right. And as soon as you say load data, it will create the folder for the table and copy a particular file. Okay. A question from Sheikh. In case of Jinyang's PC, we saw U data 1, U data 2, and so on. If we drop U data 5 or any of the table for that matter, it will drop the linked tables. It will not delete the tables. It will just delete the data. And hence, when you say select star from U underscore data, any of the tables, we say select star from U underscore data 3 or 4 or 5 or 1 or 2, it will just give you 0 results. It will not give you an error saying table not found. It's just data not found. All right. Good question. Very situational. All right. Okay. So when we don't specify the location, this is where the folder will get created when we load the data into it. Okay. All right. Now coming back to it. All right. So this is one thing we have already talked about this part. All right. So it's either located in this place, the data, or it's located in in the location that you mentioned. All right. Now, sometimes you may want to export the data into a file. In that case, you can say things like insert into local directory or insert into directory. If you say local, that means it will be saved in the in your console machine. Otherwise, it will be saved in the HDFS. All right. All right. So Hive does not provide you indexes. Instead, it provides you partitions. Okay. Let's say you have many gigabytes of data. A general strategy would be to break it down into small files so that when we are querying, when we are saying select star from my data where A equals to B, instead of going through the entire file set, it will only go through those files which contain that particular value. Okay, that means we can decrease the total disk lookup using the partitions. Okay, so the data is stored in different files based on various combinations of columns. All right, I'll show you an example. So you have to define the partitions using partition by in create table. All right, and partitions can happen on multiple columns. Okay, so you can, this is again a little bit more hands-on exercise, and uh, okay, so let's try to see what happens in this case. Okay, if it's not clear, please feel free to interrupt. Okay, so please feel free to ask questions. Okay, let me explain this. Let's say you have a table called employees. Okay, you have a table called employees, and let me move this somewhere else. All right. So let's say we have a table called employees. Let me create this table for you. Okay. And there is a file called the amp. Okay. The amp, where is this file located? All right. So here we are. Let me see if there is cat. All right. So there is the amp file and there is another file called the amp1. All right. So there are two files. One has 3 columns. And second one also has 3 columns. Okay. So you can see that. So the amp and the amp1 both are comma separated files having three columns each. Okay. So let's say we create a table called employees and load this data there. Okay. Let me just use this. Okay. So stay focused here. So we are creating this table called employees and then we will load data into that. I'm hoping that I'll get a prompt. And loading from local is only possible using the console, not from the Hive server. Or let me try doing this. I'll just upload it into web server and then do it from there. Okay, let me cancel it. And let me Hadoop fs make directory and I call it say EMP. So I'm creating a directory in HDFS and Hadoop fs copy from local into my the amp1 into EMP. Okay. The same file should be available in the data folder as well. So Hadoop fs minus ls slash data hive. It should be there in this folder as well. Yeah, you can see there are 2 files already. Okay, these are very small files. So you can use the same data from here as well. Okay. So now let me go to the browser. So what is it that we are trying to achieve? We're first trying to create this employees table. Okay. All right. Not here. We are going to use query editor like this. If you don't get the console, this is a good way to do it. Okay. So right now, this time we did not specify the location. We are saying we are creating employees table. Okay. Employees table had 3 columns: name, salary, and degree. Okay. And it's partitioned by a next column, 4th column called qualification. So in total, this employees table would appear to have how many columns? 4 columns. Okay. Okay, so this is already created. Good. Now, if I say select star from employees, you can see how many columns are there? 4 columns. Though the 4th one is actually a column on which partitions are created. Good. Now let's I'm going to use this command. Instead of using local, I'm going to use this. I'm going to say home, not home, user slash Sandeep Giri 9034 slash EMP. This is where our data got copied, right? I created a new folder and then uploaded the data in these files into this, right? Now I'm saying instead of directly copying the data into my destination folder of employees table, I am using the load command. Let's see if it works. Okay, let's see if there is something in this table. Good. So what you see here is we are saying load data from this file into this table called employees. And this file only had 3 columns, right? These first 3 columns, name, salary, and degree. Fourth column, we have explicitly mentioned that it is qualification equals 1. Okay, which means if when we query this table and when we say where qualification equal to 1, we are going to scan only the first file. Okay, so keep this in mind. And also let me, not this one, this one. Okay, so what we have done before this is copy slash data slash hive into this folder. That's all we have done before this. Okay, we have copied this data into this folder and then we are running this. All right, so now keeping that aside, let's also load the second part of the data. So fourth column, the column on which partitions have been done, is being specified. The value of that particular partition is being specified by us explicitly. So you can see for the records loaded from the second file, the fourth column is 2. For the records loaded from first file, the records are 1. All right, good. Also, there are a few things to note here. There are a few things to note here. Okay, now the folder that we uploaded the data, EMP, would be empty. You see, the data is removed. So when we are loading the data from HDFS from a file, that data will be moved into the warehouse or the location where employee table is kept. Okay, if you want to understand what's going on with employees here, okay, there is a way to, let me see, DFS CP DFS copy data hive into, I'm just experimenting with this command. Okay, let's see if it works. All right, never mind. All right, never mind. So instead of that, I think what we should do is we should use the HDFS. That will be better. Okay, so here are the steps. Those who want to experiment, they can experiment with me. This is on console. And this is on Hive. All right, never mind. So moving ahead. Okay. All right. Let me just copy paste all of this to you so that you can also try if you want at later point of time. Okay. Did I copy to one particular person? No. Good. So what I was trying to demonstrate here is that when I say select from employees, both the files are getting queried. Okay. Also, let's take a look at where is this data. If you say describe formatted, okay, if you say describe formatted, it will show me all the details about this particular table. Okay, so you can see that this table is located at this location. See, it shows that it's located in HDFS. This is the name node, and it's running a web interface at 8020 and this. Okay, sorry, I think you'll have to use -cp. Okay, so I think Hadoop fs -cp. Yeah, instead of copy, use -cp. All right, here -cp. Okay, so let's take a look at how does this warehouse looks like. So apps, Hive, warehouse, and what else was there? Sandeepgiri.db, and then employees. Sandeepgiri.db, easier way would be to use this. Yes, clear this. Okay, now you can see. Now, is it visible to everyone? So when we created a partition table, this folder was created called employees under the hood. And when we copied the amp file, the first file, and we mentioned that qualification equals 1, it created a hierarchical structure. Okay, for every partition it has created a separated folder, which means there can be more data pertaining to qualification when you can copy more data there as well as here, and also you can keep on creating more and more partitions. Is everybody clear about partitions? All right. Because the main problem which all of us face with Hive is not the query. It's only where is my data? Okay, it's only that. All right. It's only you know, where is this table created? Is it getting created in MySQL? Is it where is the folder? What happened to the folder? Okay, so great. So this table is by default created there if you don't specify the location. To find out the location of the file, you can say describe formatted employees. Okay, describe formatted employees. All right. Yes, so everybody is on the same page. Now, had there been more columns on which we were creating this, we will have to specify the values for those columns and the structure folder structure there'll be one more label. Let's say we are saying year equals to 2014. So there will be one more folder inside this one, year equals to 2014. All right. Good. So with respect to the DDL, data definition language, Prashant, yes, I need to understand what does it mean by composite. Yes, like this, you see. Here we are saying there are three partition, so three columns, year, month, and day. All right. So you can modify the table columns in the same way the way you modify Oracle's tables. So it's not called horizontal partitioning, Zhenyang. Okay, it is not horizontal. Basically, it's just partitioning. Horizontal partitioning means that we are kind of distributing data. It's not horizontal. I don't know where that this keyword came from. Horizontal partitioning. I'm not sure. Okay. All right. So you can modify the tables like the usual way. And sometimes you don't want data to be deleted when you are dropping the table. So to be cautious while uh, manipulating this data, you make sure that to be very cautious while manipulating data, make sure that any data that you don't own, mark it external. Okay. Create the table. Only difference is this keyword called external. Rest is exactly same. All right. Sometimes you may want to load an external table, say from S3. In that case, you can say create external table, mini-wiki stats, and location is S3. In that case, whenever you're querying this table, mini-wiki stats, you will be querying S3. It might take a lot of time. Okay. And this external table you can have external partitioned. You can define a table, external table with partitions, and keep on adding partitions, some from HDFS, some from S3, and so on. So you can have partitions from different sources. Okay, so a partition is equivalent to a table in itself. Okay, so every partition can have different location of data. All right. So each table has got a location. By default, the table is in a directory under the location this, if you don't specify a location. And you can override this location by mentioning the location keyword after the row format. All right. If you're using load data command, in that case, data will be copied in case the data is local, as in the console. Otherwise, data will be moved if it's in HDFS. Dropping managed table deletes the data at the location. If you're dropping external table, it won't delete the data at the location mentioned above. And the meta store is in the relational database. That was a quick way of summarizing whatever we have learned so far. All right, so Hive provides you the standard functions, select statements, and aggregations. Now, the other important aspect of SQL is views. Who knows about views? Yes. All right. So in SQL queries, when your query becomes very complex, a easier way to deal with it is break down the query into views. Let's say you have tweets and you have a query that cleans the tweets. Okay. Although The same can be created as a separate table, but if you create the separate table, it'll take more space. Second, the data might go stale. So in case you do not want to keep intermediate data, the only objective in your mind is to simplify the query, then you use views. Okay, you can also create custom functions that I'm not going to go into, but if you want to go understand that how to create custom functions in Hive or Pig, you can go through these slides as well as the recordings which are shared with you. Okay, so that way you will be able to learn how to create custom functions, because there would be certain aggregations, certain translations that are not there in Hive that you may want to implement. In those cases, this particular step explains that. All right, so here is another caveat. Yes. So Prasant's question is, so far we have read text data. Do we have any adapters? Yes. The row format that you study here, okay, the row format that we study there is an example. Okay, where is the query that we were dealing with? Here. Okay, so you see the row format here. In case you have a binary data, you can specify the row format and then the library that you're going to use for that. Okay, you can, so we call these things okay, I'll go back to where were we. Just give me some time. So yeah, so we call these things as survey. Okay, let us take an example here. Okay, we are exactly at the right page. Okay, so let me so Prasant's question is, right now we were happy because we were simply reading either comma separated file or tab separated file and everything was good. But what if we have different kind of data, say in a binary format, say in a JSON format, or say in an XML format? Then how do you deal with it? That's where Survey comes into play. Survey means serializer, SER means serializer, DE means deserializer. Okay, so there are many organizations which provide Survey. Okay, also you can customize Survey, you can write your own Java code which can convert the raw data into records. So Survey converts the raw data into records, and serializer converts the table into raw data. Deserializer converts the raw data into the table. Or okay, and that's the whole idea about surveys. They can be customized. Imagine that this we will cover in an exercise. Imagine that you have Twitter data downloaded in the form of JSON. Okay, take a look at this particular folder. Okay, and if you want to load that data, what you're going to do is you are going to say create before this you'll have to say add jar, as in add that particular jar, locate it, this jar we have provided here. Okay, so you will have to add jar. Okay, not here, inside Hive. Okay, so you can try it out at your time. Right now take more time. Okay, so first you have to say add jar and give the absolute location of the jar in the HDFS. And please pay attention to 3 slashes. And once that is done, okay, once that is done, then you create your table. Okay, and then you say row format survey this. This is the name of the class that is the entry point for translation of raw data located at this place into something like a row of this table. Okay, so this is how you can read custom formatted data. You can get Surday for almost everything. XML Surday. Okay, so you can get the XML deserializer. Okay, and inside the release you will get the jar. You can download it and put it in your HDFS, and using add jar command you can load that. Sounds good to you? All right, so all kinds of formats you can load in Hive and then handle it. Saptarishi's question is, how do I handle a situation where the data is in local file has changed after it was imported to Hive and the table was created? Okay, so if you basically overwrite the data, just delete the old data from Hive, the location, and then upload it into that location. Also, this load from local has one keyword. Okay, it has one keyword called overwrite. You see the overwrite, you can use this. You can say load from local overwrite into table. So the entire data will be overwritten. All right. Otherwise, you'll have to programmatically scan, like keeping a track of the records. So that's not a generally right thing to do. Was I able to answer your question, Saptarishi? All right. So we can create views and process we can create views. Say, let's say we are saying create views tweets clean as this hues query. So every time when we execute select star from tweets clean, we are going to execute this query internally. That's what is our view. Okay. Now, uh, now a minor caveat with respect to the sorting and distributing. Okay. You remember our discussion earlier when we have a big file and we are doing map reduce, right? And we are saying reducers equals to 2, and there were 2 files created, and now how to concatenate these files? You remember that problem, right? This is exactly the same problem faced by Hive. So when we say order by X, so when we say select star from U underscore data order by movie ID, it's going to ensure that it just have one reducer internally, because every Hive query uses MapReduce, and by default the order by X is going to use single reducer. Now that was something not acceptable. So people came with an idea of sort by X. Okay, sort by X, as in first order the data by particular X, and then, okay, all right, and then use this. But this was not sufficient. Okay, it's equivalent to saying we have so many reducers, but every reducer is going to have its own sorting. Therefore, we needed a partitioner earlier. In the similar way, Hive people also came up with another syntax called distribute by, meaning we have to order the data and distribute the data based on the same criteria. Okay, therefore a new way of ordering came into play called cluster by. In simple words, you can use cluster by, okay, cluster by X, meaning first partitioner as well as the partitioner as well as ordering will be based on column name X. All right. So when you have multiple reducers, make sure to use cluster by X. Okay. Okay. So Hive provides bucketing as well. Okay. Bucketing as well, as in you can see that. So we can say cluster by a particular column and say these many buckets. All right. it is essentially equivalent of saying 32 reducers. All right. One more thing that has happened with Hive is that they came up with their own storage format called ORC file. Earlier it was RC file. They came up with a format called ORC file. Using ORC file, Hive recently have started supporting the modification of the data. Okay, so if you can instruct Hive to store data in the ORC format, and then you can use insert into, update, delete, and so on. All right, so that's pretty much. And so basically when you're creating, let's say ORC file, you can use this. You can say create table I this, and then insert values into this. Okay, I will try to demonstrate if this works. All right. Okay, so it looks like it's still busy doing something. Select star from I star I. Okay, so you can see that, and so I'm just inserting arbitrary data. All right. Okay, question from Prashant is, does these additional feature of ORC come at the cost of performance, or it has further enhanced the performance along with usability? So basically the main problem it solved is, earlier we were not able to modify the data using Hive, but ORC file, since it gets updated, we are able to modify it. Had it been like plain text file and we try to modify something, it will rewrite the entire thing. That was inefficient. ORC file was very efficient. Okay, it was very efficient, and it was same as like the way database stores the data under the hood. In the same way, using ORC, Hive tries to store the data in an efficient manner on HDFS. Okay, so you can try this. This is new thing that has happened with Hive. All right, we have gone through this. Now, you can try this assignment. So for every movie, you have to find out how many users have voted for it. And for movies having more than 30 ratings, what is the average rating? For the second problem, you can try using the views or try using the subquery. Okay, or try creating a temporary table, another table, and then try to use joins. All right, so you can try using finishing these assignment. Is everybody with me? Yes, so this is your assignment, and other than that you have to try out the these two exercises. One is this, and other is ORC file, other is this. Okay, so these are the two things you have to try out. I'm going to give you this file right away so that so these assignments are available in LMS. Okay, good. All right. All right. So that's pretty much about Hive. So we gave a decent amount of time to Hive, and I think we did good. So tomorrow we are going to talk about NoSQL, and then we will start with Scala. Okay. Or maybe we'll just finish with everything related to Hadoop tomorrow. First, NoSQL and HBase, and then other components such as Scoop and Flume tomorrow itself. All right. Okay, so that's pretty much about, yeah, Hive. All right. We spend good time with Hive because we are going to use it in the Spark as well. Okay. Pig, since we are not going to use much, therefore we have skipped it, and it's not being used too much by people. All right. So thank you very everyone. Thank you Ali. Thank you Anup, Barsha, Jamil, Jeniang, Karthik, Manjunath, Mohit, Nada, Nitin, Omkar, Prashant, Priya, Ramana, Saptrishi, Sheikh, Stephanie, Sundar, Tad, and Thomas. See you tomorrow. Have a great day.